All right, final Pencast. I'm not singing that, but whatever. All right, so this is number one from problem set 11. We have a parallel plate capacitor. On the top one, we have positive charges. Bottom one has negative. And then we have two slabs of linear electric between them. Okay, these slabs are filled, each slab has a thickness A. Setting up the problem, the boring part. Total 2A between. Slab number one has a dielectric constant of, oh crap, of 2. Yeah, 2, okay. So that's the top one, E sub r equals 2. And this one is E sub r equals 1.5. Anything else? Free charge on the top one is positive sigma F. This one has negative sigma F for free. Just adding in everything, we have our negative charges, some positive charges for the bounds, negatives right here, positives right here, and that's all I really need right now to set this up. So part A says to find the displacement in each slab. So D is, find for linear dielectrics, is epsilon E. E is, if we take these to be infinite plates, we know that the electric field from that is sigma over epsilon. And E inside here goes from positive and negative, so in the positive z-hat direction. So D equals epsilon times sigma over epsilon in the z-hat direction. Now sigma is the free charge enclosed plus the bound charge. All the free charges on the plates, so there is no free charge in there, so it's just sigma bound. Epsilons cancel, so D equals sigma bound in the z-hat direction for each slab. Part B, find the electric field in each slab. Once again, the electric field is, if we assume these are infinite sheets, is sigma over epsilon in the z-hat direction. Epsilon is epsilon naught times epsilon sub r. So for the first one, find this is 1, this is 2. Yep. Epsilon 1 equals sigma over 2, so 2 epsilon naught in the z-hat direction, and E2 equals sigma over 1.5 epsilon naught in the z-hat direction, or multiplying this by 2 over 2, 2 sigma over 3 epsilon naught in the z-hat direction. Part C, we now need to find the polarization. Polarization equals epsilon naught susceptibility times the electric field. Epsilon naught susceptibility sigma over epsilon naught epsilon sub r. Epsilon naughts cancel. The susceptibility is epsilon r minus 1, so this is epsilon r minus 1 sigma over epsilon r in the z-hat direction. So the polarization for the first slab, we plug 2 in here, 2 minus 1 is 1. And then we have this over 2, so sigma over 2 in the z-hat direction. P2 equals, now we have 1.5, minus 1 is 0.5, over 1.5, multiply those both times 2, you get 1 over 3, so sigma over 3 in the z-hat direction. Part D, we need to find the potential difference between the two plates. So between the plates, integral of E dot dl. Between the two plates, we just have the slabs. So for this first one, we're going to have E times the length, which is A, plus E2 times the length, which is also A. So A times E1 plus E2. So V equals A sigma over 2 epsilon naught plus 2 sigma over 3 epsilon naught equals A. This is going to, if we multiply that times 3 over 3, 3 sigma over 6 epsilon naught plus 4 sigma over 6 epsilon naught. Then we get that V is 7 sigma A over 6 epsilon naught. That's part D. Part E, find the bound charges. Sigma bound equals P dotted with n hat, which is P in the z hat, dotted with z hat, which equals P. So sigma bound for the first slab on top equals negative sigma over 2, since it's negatives. Sigma bound 1 on the bottom equals positive sigma over 2. Sigma bound 2 on the top equals sigma over 3, negative, because that's also negatives. And sigma bound 2 on the bottom equals sigma over 3. This sigma bounds. And then the row bounds, we have del dotted with P. Sigmas are constant. This is a uniform distributed charge. So this is a del dotted with a constant. Del dotted with a constant is 0. Before we go into part F, we need to put these in their right spots. So right here at the bottom, this is the second slab. So this is sigma bound to bottom. This is a positive sigma. This is just a sigma over 3. Right here we have the negative. We have a sigma over 2. And then in here we have both a positive sigma over 2 and a negative sigma over 3. So if we put those together, those subtracted from each other, we get sigma over 6. So this is in here we have sigma over 6. So these are the bound charges at their 3 locations. For part F, we're asked to find the electric field again. So electric field, in between here, we have none of the free charges. We only have the bound charges. So we have the sigma over epsilon naught. So for the first slab, we have sigma over 2 and sigma over 6. So E1 is sigma over 2 plus sigma over 6 over epsilon naught. And you add those together, we get E1 is sigma over, this is going to be 3 sigma over 6. This is going to be, wait. Oh, sorry. Sorry, that should be a 3. So then this is going to give us sigma over 2 epsilon naught in the z hat direction. E2 equals sigma over 2 plus sigma over 6 over epsilon naught in the z hat. And then when you put that together, E2 equals 2 sigma over 3 epsilon naught in the z hat direction. Done. Forever. No more Pencast.